All right. So, without further ado, in the tradition of big meetings, uh, Jax, would you on with the show? You're next. Introduce yourself and tell us why you're here.
Oh, okay. Well, I think most of the people here we've met many, many times before. Hi, Bob Armstrong, out there in Colorado with me. I'm Jack Woehr. I live in Colorado, former FIG board member a long time ago, long time ago, and current IBM champion and MongoDB creator status, and I'm still gainfully employed uh, as a programmer. I was interviewed on the MongoDB podcast. If you go Google the MongoDB podcast about 4 podcasts ago, and there's a funny exchange there where the fella asks me, Mike asks me, when you say programmer, do you mean developer? And and I told him the story about what, before I was a programmer, before I was an active programmer, I was a bus driver. And one of the old shop stewards told me at the bus company, he said, the problem with this place is nowadays there's too many transit operators and not enough bus drivers. And I feel, and he got the point, that there may be too many software developers nowadays and not enough computer programmers. But so for at least a decade, at least a decade, and I think a little longer, once a year, I have been visiting with my old friends. They've been friends for a long time, so they're old friends, and they're also old friends all getting old together. Um, I've been visiting with you all and discussing the state of quantum computing in the current world. As you may recall, I became interested in quantum computing around the year 2000. I had always been interested to a certain extent in quantum mechanics. As I said at IBM Tech Exchange in Las Vegas in September of last year, um, in an interview when I was in high school, one of my chemistry and physics teacher was a woman who'd worked on the Manhattan Project. So from 1967 on, I had some kind of idea of quantum mechanics, not a very clear idea, and I never read up on it over the decades. And so by 2000, I was very interested in the problem of quantum computing, not so much for what quantum computing itself can do, but the fact that the advent of quantum computing would mean that there were more and more quantum physical experiments. Every time you operate a gate in a quantum computer, you're basically doing a quantum mechanical experiment, and that I felt it would advance quantum mechanics to itself, just to have quantum computing being on the table, on the agenda. And it certainly has, as I think I mentioned before. Dr. Zlatko Minev of IBM some years ago, about 2019, 2020, he had a team that proved that a quantum leap, which at one time was supposed to be utterly instantaneous, where a quantum entity changes its state from like 0 to 1, seemed to be instantaneous. It had been suspected for decades that it was not actually instantaneous, that there was some transition time. And Zlatko Minev, using IBM quantum computing equipment, was able to actually prove that. He and his team were able to prove that. And not only did they prove it, but apparently when something's about to change its state, it goes kind of bumpity, 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 bum, bam, and you can actually catch it and keep it from changing its state. So he made it so quantum computing has fulfilled my expectation that it was going to, write new chapters in the theories of quantum mechanics, and it certainly is doing so and will continue to do so. But the big news, again, I began maybe 10, 12 years ago coming to Fourth Interest Group, and I was at that time doing some interviews for Dr. Dobbs' Journal with people, and I was lucky enough to talk to communicate with two Nobel prize laureates on this subject, along with many, many other very interesting people. And by 2009, 2010, I'd become convinced that quantum computing was no longer a game for postdocs. It was actually engineering, and it was going to happen. And I said that from 2010 onwards. I believe by around that time is when I started talking to you all. And by 2014, February 2014, there were articles in Time magazine about quantum computing, and I've kept you abreast on how a lot of the processes are getting bigger and bigger. And the big news, I think, for 2023, 24 has been that it is going commercial in a big way. There are IBM and AWS and others are offering online, pay by the QPU second, um, quantum computing as a commercial offering, and they had been playing with this for some time. But it's actually at this point the processors have gotten. There's two things that have happened to the processors that have made this useful. Um, Certainly, many organizations were interested in it. Everyone um, in the financial, and especially the financial industry and chemistry, optimization, quantum computing promises to speed up optimization algorithms, where you have many variables that have to be balanced to produce a minimum cost function. For instance, one of my favorite examples is as a professor I knew um, at the Colorado School of Mines, and I may have mentioned this before. That the professor at the School of Mines was trying to, he had spent his whole career since the 60s working on algorithms, both as an employee of the mining industry and later returning is the return on open pit mining. This is one of those, add apples to oranges kinds of problems. You have to factor in the quality of the ore, the amount of the ore, the amount of diesel fuel you use to extract it, the cost of labor, the cost of transportation, the value of it, the fluctuations in the value of the likely fluctuations in the value of the ore when you get it to market. And these algorithms took days to run on supercomputers, and he was looking forward to an era when optimization algorithms ran faster. So it's certainly been of interest, and different companies, Barclays Bank, other huge institutions have spent millions of dollars detailing employees to work with the very early NISQ, noisy intermediate scale quantum devices, trying to see if these algorithms really can be made to work. Whether they produce accurate results on the early hardware was not as important as to whether the algorithms themselves could be discovered. You may remember early in the history of digital binary computing, people were arguing about the best algorithms for doing a 16 by 8 divide. Well, that's about where quantum computing was a few years ago. They would just basically say, it was build it and they will come. They had the hardware, and they said, we believe because of the existence of certain proven algorithms, a very, very small set of proven algorithms, that there will be quantum advantage for a large set of algorithms that we have not yet discovered. Would you please discover them? Here's the hardware. Would you please discover these algorithms that will make this valuable? Because we're manufacturing this hardware and we'd like to sell it. And IBM certainly has stepped to the fore in this, and even Microsoft is at this point is using IBM stuff. And the big news is that even though, as I said, in the past, over the past decade, companies have been spending millions of dollars detailing physics students and computer science students to working on this and seeing if they can find something useful to do with this. What's happening now is they're finding useful things to do with it, because the two things have happened to the hardware. One is they have more qubits now. They now have hundreds of qubits on these devices, and the devices that have the two kinds of devices that have delivered the most return are the superconducting transmon qubits, which is what IBM does, and the ion trap qubits, which I talked to you about, I think, in 2010, and which are still around and were the first devices that they actually were made to work. And they're not as fast as the superconducting transmon qubits, but they have longer time before relaxation of the quantum states. So the IonQ and IBM at the moment are kind of emerging as dominant, with Google in there too, but Google isn't as public with what they do, so it's a little harder to tell where they are. IBM and IonQ are very upfront about this. Photonic doesn't seem to be going anywhere. Some people may disagree with that, but I've not seen a photonic uh, company using photons instead of like electrons or ions like the other two do, that have made any significant commercial offerings. But IonQ and IBM with their superconducting transmon quantum computers, you will remember that a transmon is an anti-transistor. It's two layers of superconducting material with a non-superconducting material sandwiched between it. And if you increase the voltage on one side, you change the frequency on the other. That's basically how a transmon works. And that's how a Josephson junction works. A transmon is composed of thousands of Josephson junctions. Um, so they seem to be the successful approaches so far. Ion traps, where they actually move atoms around in space and make them bump into each other, and that's slower than the superconducting transmon, which is totally electronic. But they both work, and they both seem to be working. And number one, they've got more qubits. As I said, this is what's changed. They've got more qubits, and two, the fidelity of the qubits is increasing. The hundreds of qubits, of course, and you only need 40 for your algorithm. You can have, you can have 40, 40, and 40, and you can have them vote and say what they do. So you end up with greater and greater fidelity of these devices, and they're up there on the web, and they're there for public exploitation. You just have to pay. What has happened to the free access? Well, on IBM, they've sort of reduced how much you can use, because in terms of the devices they wish to dedicate to their free access system, IBM quantum computing, just look up IBM quantum computing, the IBM quantum experience, you can find, and you can get an ID and log on and use this stuff. But you used to be able to use it pretty unlimited if you could get time on the QPU to use it. And it became harder and harder as thousands and thousands of people began using this. And now you're limited to a certain number of computing seconds per month. So the privilege of free access is starting to diminish to a certain extent. What's happening to Qiskit, IBM's open source quantum information science kit? Well, it is stabilizing, and it is the basic elements of it. When they originally issued it, they had all kinds of play algorithms associated with it. They kind of threw that away and focused on the core Qiskit, where you could formulate a quantum computation, assign the operations to the gates, and execute it on the remote system, whether it's IBM's or one of their competitors, because their competitors are using Qiskit since it has pluggable back ends. You just say which back end you want. I want a quantum Inspire back end. I want IonQ back end. I want IBM back end, and you just load the plugin and you can communicate with the different vendors. So it's become an international standard, and everybody's using Qiskit. But Qiskit, a lot of the fancy stuff, that was early on and was kind of, just basic, they kind of took it out of there. And so you got the basic Qiskit engine, which can formulate the quantum computation and connect to a provider and deliver it. And you've got the simulator, Air, and they're not adding more to the open source Qiskit. What they're doing is that they're going with what they call primitives. And primitives are basically, you may recall that in previous years I've said to you, they call this quantum assembly language, but it's not. It's really quantum microcode. These are the very, very basic operations that the processor can do. And when a quantum assembly language evolves, I used to say, when a quantum assembly language evolves, it will be at a much higher level than this stuff we're missing now. H gate, X gate, X gate, that kind of thing that we were dealing with at the QASM level, the quantum assembler level. Like I said, it wasn't really quantum assembly, it's more like quantum microcode, and the assembly primitives will be built out of multiple ones of these gates. And that's what's happening now. These things called primitives, basically, they're allowing different vendors to package. They started with Qiskit runtime, and that basically said, well, up to now, you've had to do the classical part of your algorithm, and then you do the quantum part, and you send that to the cloud. Then it comes back, then you continue your classical part. Then you send another quantum computation to the cloud and wait for it to come back on the internet. Well, now they delivered a few years ago Qiskit runtime, which allows you to package your whole computation. It goes up to the server, and the classical and the quantum portion both run on the server. So there's some time. You may have to wait for your time to use the quantum processor, whatever. But if you have a reserved time, and then if you're a paying customer, and anytime you go up there, you send it up there, the whole computation runs in the cloud, and the result comes back to you. Okay, so coupled with this is the concept of primitives, which is that different vendors of different devices can provide very, very high level operations that are composed of possibly thousands of gate operations, and program them into their offering and offer them as primitives, i.e. real quantum assembly language, not quantum microcode. And they don't have to show you what's inside them necessarily. You just have these, you have manual that tells you, what operations you can do. You put it in a Qiskit runtime program and send it to the vendor. So an awful lot of development now is happening. It's not open source. It's happening, with the different vendors, and these are trade secrets. How we're going to give you an optimization algorithm. Here's the optimization algorithm. Here's the arguments it takes, but we're not going to tell you how it works, or something. Or maybe we are going to tell you how it works, but they're not making it necessarily open source. So Qiskit will stay open source, and you'll be able to experiment all you want at that level. Write your own Qiskit primitives, use Qiskit runtime. It's part of the open source, at least the client side of it is open source, and you'll be able to use all this. But a lot of the development now is sort of, is build it and they will come. Well, they've come, they've shown up, and companies are generating genuine revenue from this now. And it's now becoming, it's not just science now, it's becoming business. And it very much is becoming business, and it is going to be successful. And we have watched it. You and I have watched this happen over the past decade and a half that we've been talking about this, and here it comes. And that's that's what I had to say about quantum computing. I had a little bit more to say. Do I have any time, Kevin?
Yes, you have time.
Okay, and I'd given one other topic, but it's sort of a joke. But you see, like in real life, I play with quantum computing. In real life, I'm still employed and I'm working with IBM Business Systems. I am a consultant on modernization of legacy applications. Your bank, they wrote the banking code for your bank, 50, 60 years ago, and they've to a certain extent kept it up to date. But now everything has to have a web interface. They can't hire employees that know how to use a green screen or who will tolerate it. They'll leave. One customer I had a 17% turnover in their operators, and the universal reason in the exit interviews was, I can't stand the terminal emulator. And so even internally, business people who use mainframes and mid-range computers designed by IBM, which are very modern computers. They're running very, very old applications, but their software and hardware is extremely modern and extremely efficient, and the environment is fabulous, and the old applications keep running. But now the people who maintain the applications are not only long retired, mostly they're long dead, and they have to modernize these applications, and they bring in young people, and the young people don't know what to do with this. And so that's part of my job, partly partitioning this off so a small section of experts can handle the legacy side of the program and turn it into APIs. So that the programmers who may want to learn about mainframes and stuff, but don't want to learn, but can't be productive the first day on it. They can be productive the first day writing the web application that calls the APIs. They don't have to know it's a mainframe because the API structure, you know, uh, 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 will is of course, like all all web applications is totally standardized. Use Open API, use Swagger documents, and the APIs. It generates the stub code for you. So the web application programmers, they don't even have to know it's a mainframe. They just, here's the APIs, here's the documentation for the API, here's the Swagger document that documents it, and now you use code like Fast API, and it will generate the stub code for you in PHP and Node, in Ruby, whatever you want, Python. It will generate the stub code for calling the APIs, and then you just fill it out with what you do when you call the APIs. So we're modernizing these systems, and as part of that, I started looking back more at little pieces of mainframe technology that I didn't really know very well, and one of them was TPF. And I had a very funny experience with TPF. And TPF is the transaction processing facility, and it was originally called the ACP, Airline Control Program, because it was written for the airlines originally. And the question is, how do you write a transaction system that can handle thousands of transactions a second, and at the same time not sell the same airline seat twice? How do you deal with this? How do you write this code? And this thing has grown, from the late 60s onwards, and it's still there. It's still there, not just in airlines, but it's used in different, there's different enterprises. They have an annual convention and everything for TPF programmers and all this stuff. So I knew all this. I knew everything I just told you. I already knew, but then I didn't really know how TPF actually worked. I knew kind of how Kix worked, which does a similar kind of thing, but Kix is really about keeping transactions integral, but it isn't so much about how do you service a lot of them at once. It certainly is high performance, but it doesn't have all this, miraculous technology that was invented, 60, 70 years ago, to 60 years ago to make this really, really fast. And how do you handle these things in order? And how do you. So I started to look at, so I took an free IBM course. It's up there on IBM Learning, IBM Training. There's a fairly new course on a couple of courses on TPF, and I got the badges for them and everything, and they're up on my website. So I passed these courses, but it all looks so familiar to me. And I realized that the way it works back in the 80s or early 90s, when I was at Vesta Technology, I had Forth has a cooperative multitasker, and I had designed a a interrupt driven multitasker that coordinated with the cooperative multitasker. That is, you could yield, but if you didn't yield in a certain amount of time, you were preempted anyway, and the registers were still saved, and you came back where you were, and it worked. And I published this in Dr. Dobbs' journal, the source code for this. It was 80196 Forth. The 80196 processor is not manufactured anymore, but it was a very interesting control processor that came out of Intel. And I did this. So I'm taking the TPF course. I said, oh, this works just like the multitasker I wrote for Forth in the in the 1980s, and that set me off into a philosophical meditation, and it's one that I've had before. I remember that when we were standardizing Forth, we asked Chuck Moore what he thought of it, and he said, well, you've managed to crystallize what Forth was. He said, but to me, Forth is more of an approach than a specification for a programming language. And I've certainly uh, found, yes, Rolf, that is correct. If Rolf has put into chat that the transaction processing facility, that's correct. Um, uh, I found that over and over again in my career, and I think I've said it before, that the Forth approach continues to inform everything I do. Whenever anybody asks me, how do I do a program? I say, everything that was true about Forth is true about anywhere you go. It is really an approach. It's a mindset as to how you solve problems in the digital world. and I find the pattern replicated over and over again, um, in all kinds of places. There's a fellow right now in the web world. There's a young genius, born in China, came over here as a teenager, I believe. Evan Yu, You, and he is the creator of Vue.js, Vue.js, which is a framework for doing single page applications in in Node. And it is, and it's become a big business, and there's all these training facilities. He's cooperating. It's open source, but of course he's involved with these training companies that make videos that you have to pay for it. And I took some of them when they open them up for a free weekend. They offer, a couple times a year, they say free weekend. And so I take all the Vue.js courses I can because I'm using Vue.js professionally. And there's a wonderful series where Evan Yu sits down, and this is so familiar to me as a Forth programmer. Evan Yu sits down and, um, in 9 videos that are about, some of them are fairly long, but in 9 videos for a total of maybe an hour and a half, 2 hours total videos, maybe a little more than that. All the type checking and stuff that the real sys does. But basically, he says, this is what I was thinking. And I'd seen React. React is another framework for writing web applications. I'd seen React and I'd seen this, and I thought, how can we do this better? And he sits down and he writes Vue in front of you. And his whole method is so Chuck Moore. It's just keep it as simple as possible. Just do one thing. Build out of small building blocks. And he finally says, really, this is something Chuck would have said to us all the time. He says, it's not about reading the manual and learning how to use the API. You really have to understand how Vue works in every case, every little bit of it. You really have to understand it to use it effectively. And it's quite simple and it's quite small. So you can understand it and you can know what you're doing. And I have people come to me, as young programmers who are trying to, write the web interfaces for the mainframes, and they say, "How do I use this framework?" And I said, "Do you understand how it works?" And they said, "No." I said, "Then don't use a framework. Write it by hand. And after you've written it by hand one time, you'll know what a framework does, and you'll understand why people use frameworks, and you'll understand how the framework works because you'll know what it's doing because you wrote it yourself once." So Forth lives on, like the continual, avatars appearing again and again. In every age I return, Krishna said. In every age, the Forth approach returns, which is, keep it simple, understand what you're doing, factor things small, don't get carried away, don't get baffled by your own nonsense. Just simply proceed. And I find this approach in the best that IBM did. TPF is very much that. Vue.js is very much that. I keep seeing Forth everywhere I go. And that's what I had to say. And thank you for listening to me.
Oh boy, the unmute button was stuck. Thank you, Jax. I wanted to ask a question.
Please
These
do.
guys that came along and said, I don't like this computer thing, were these, I dare say, developers or programmers or computer weenies of any sort?
What are we talking about here?
You mentioned guys that came along and left because they didn't like the terminal emulator, some other aspect of the
No,
user
no,
interface.
these are data entry operators. That's it's not. They're not developers. I'm talking about, business computing. I have a customer that is in the Fortune 150, and they were having 17% turnover because their data entry operate. Their people, they do invoices, they process shipments, they, tasks, and they'd hire people, and they pay them good. They've got oh, and they're inclusive. It there's people of every ethnic group and people of every gender, and they're totally totally inclusive workspace, and they're a wonderful place to work. And the people were leaving at a rate of 17% because the applications were aging, and they had to sit there and like cut and paste data from one terminal session into another to get any work done. And then they had to like take some of it and put in spreadsheets and process it a little bit in spreadsheets, and then take it and paste it back into the terminal emulator. And they were saying, this is nonsense. If I do anything else in the world, I go to a web application, it does everything for me. I just say this, and I copy this field, and it knows how to work. What's with you guys? What happened to your business? And the answer is they fell behind in modernization. This Fortune 150 company fell behind in modernization, and that's where I'm making my money. We're going in there and we're factoring old COBOL code into APIs, and we're not using, and on the back end, we're using the classic languages. We're still using, on the IBM we're using RPG. It's the most efficient language to write something in. RPG plus SQL. You write it. These are all database systems, basically. And
Just to be sure, when you say the classic languages, you don't mean ancient Greek.
no, I mean the classic computer languages. COBOL is still there in a big way, and RPG is there on the IBM I. These languages still exist. They're still maintained. They are still modern. They're very, very efficient on these platforms because the platforms emerged with the languages. So that's how these things work. And RPG has become a modern language. You can teach it to somebody in a week. And mostly RPG is just an egg cup, and the egg is SQL statements. So it's not, you're not really writing a lot in these weird old classical languages. You're just using them to launch SQL statements into an API. The tools are there. It's all automated. You can say, okay, make this an API, takes this arguments and returns this. And all you have to do is like fill out the code, you make your SQL statements and fill out the return API, take the parameters, put them in the SQL statement, check them, check for authorization. I mean, there's a lot of complexity that's there when you make APIs for web application. That's there when you make anything. There's security. I was asked what are going to be the great challenges in the developer world in the coming years, and I said there's two things. One is the constant threats against your system is going to be one of the big annoyances, and the other big annoyance is here comes the government to tell us how to do it. So that's going to be the real challenges in the world. The interaction of the threats that are very, very real, and they are getting. There's more every day. More and more of my practice is involved with security. I'm getting diverted from everything else at this point into dealing with security issues, and making sure things are secure. And then, the other thing is here comes the government and the cybersecurity initiative, and they're going to sit here and tell us how we should do it. And that's going to cause problems for everybody, because, here comes the government. But I'm glad they're doing it. I mean, I don't want to criticize the fact that they've finally woken up to this problem, but of course government is a blunt instrument always.
Sure. So Edward Boraski asked about Forth, the new model. Do you own that? Can you reissue it as an ebook?
I do not own it. I cannot find the company that owned it went out of business. I have tried over and over again to trace this. The company that hooked me up with them, of course, was Kaner CMP publications that owned Dr. Dobbs, and I can't find them anywhere. And they were bought by somebody else, and then they closed down Dr. Dobbs. My editor, John Erickson, God bless him, had to retire. He came down with Parkinson's, and that was really the end of Dr. Dobbs. They handed it over to Andrew Binstock, but it only lasted a couple of years after that with Andrew as editor. And I cannot trace who owns the rights to that. I'm not a lawyer. I don't know how to research this. If anybody can tell me who owns the rights to Forth, the new model, I'd love to know that, but I haven't been able to find it. And people have asked me this question several times, and I just simply don't know the answer.
When will the copyright expire?
Well, I don't I'm not a lawyer. I'm not a copyright lawyer. I'm going to have lunch with one today about a different total subject. He used to be a congressman. Now he's just back in the intellectual property field. Maybe I'll ask him today. Um, the other
The other,
question, there's another question. What happened to PL1? Nothing. It's still there. PL1 is still there on the mainframes. There are still courses, IBM training courses for doing PL1 under ZOS, and ZOS is the modern operating system that incorporates the old MVS plus USS, Unix System Services. All the IBM's mainframes now have two faces. They have the legacy face and they have the Unix face. And USS is the Unix base of the Z mainframe, and MVS is your classic operating system, with JCL and all that stuff. And PL1's still there, and there's still courses for learning it on ZOS, and they're free, and you can take them on the IBM website. PL1 is also present, if you want it, on the IBM I, the mid-range platform that I mostly work in these days, except that I think that it may be on the ropes in terms of IBM's interest in maintaining it. We'll see what happens, because it's not clear that anyone in the world is using it on IBM I anymore, but they certainly are using it on the mainframes. It's still there.
Marlon Overson may be able to help you with this question of who owns the copyright to Forth, the new model. The other thing is that if we wait for the copyright to expire, or uh, find out if the copyright is abandoned, uh, it might give us a gateway. Given that there's some way to uh, publish it other than publishing it and waiting for somebody to say, no, no, you can't do that, I own the rights. Uh, Perhaps would you be willing to publish it as an ebook?
I would be willing to publish it. I think I'd want to revise it. I think I was a bit of a precocious ass in that book, and I would tone back some of my remarks, and I would also maybe modernize it and get some input from Brad and from other people who have continued to implement ANS standard Forth, and or what should have been ANS standard Forth if the process had not really basically been abandoned. I would want some collaborators on it so I could make sure that I was up to date in what's actually happening in the Forth community. Yeah, that is. I don't know if that's it, Don. I don't know if that's the book. I'll have to look at that. I'm clicking on that link now from chat and seeing if that. Yeah, that's. It's possible that this has been. Yeah, I don't know who's selling this, and it's probably a used copy.
Mm.
And the other thing, I knew a fellow, a very famous fellow, whose name I won't mention, who basically would pirate old books like this and republish them without license because he sensed that nobody was watching. So I don't know if this is a used book. I don't do. It says hardcover. There was no hardcover edition of it that I know of. So I don't know what the heck hardcover means. I don't know what this guy has or who this is. And I certainly was not asked anything about it. And I don't know what the guy's selling. He may be just be reprinting it for all I know. I don't know who this person is. M&T Books. M&T Books was the publisher. That is correct. Hardcover, 315 pages. I never saw a hardcover edition of it. I don't know. I don't know if it ever. I have no idea whatsoever what this is.
Well, uh, were you would you be willing to put it in the public domain, uh, or would you want to make money off of it?
Uh, I I would not. Uh, I would issue it at this point as a free ebook. I do believe that that is the direction I would go with that, especially if I had collaborators like Brad, and to help me update it and make sure that I'm telling the truth about the modern the modern language, because I haven't, I have not been very closely following Forth. I read the stuff that you guys publish, and I've looked at, you know, um, several of the Forths. I use G-Forth all the time for little things. There's things G-Forth is useful for. I just like bring up G-Forth and I do some, hex to binary conversions and stuff like that. But G-Forth is really the only Forth I've looked at much in the last, 25 years. So, and I wrote my own little, object-oriented Forth language, called Fiji at one point around 2000, and that's out there on, it's definitely. I think I have it on GitHub now. I had it only on, uh, you know, the
Will you be
SourceForge.
talking about that at some future time? BG? It looks
A
like
Java
Jack,
interpreter with an object. Say again?
you're breaking up, Jack. Bill,
Oh,
Reg, Bill, you ready to go in a minute or two? Okay. Any other questions last minute? Wrap it up quick.
Jack's a question, a comment and a question. One, where are you actually living? How far apart are we? We should get together.
yeah. Well, I'm down in.
Do that
I'm in.
offline.
Yeah.
Oh,
Okay.
okay.
Well,
Yeah, the comment on terms of quantum transitions, guy who's really bugs me that I can't remember his name and I can't remember a trigger to it, but makes the point that in something like the emission of the frequency of a cesium transition, the output is over kilometers long, and I can't remember nanoseconds, if you will. Yeah, kilometer
the
nanoseconds
grandson
long.
is.
So the transition just simply is intrinsically not instantaneous. The last thing, and maybe this should be also I saw your article about Mongo, and I'm wondering what is unique about Mongo. I've seen a lot of stuff recently about vector databases and their use in AI. What makes Mongo different than all other databases?
An answer in
Well,
30 seconds.
yeah. Mongo is a document management system. It basically is a bunch of JavaScript programmers who went crazy of JSON documents. And that's basically the Zen of Mongo. And it's a fully developed ecosystem. It's a very well managed company, and it's very interesting. Go to mongodb.com and start exploring. It's open source.
I'd like to thank Jack a lot. Thank you so much, Jack. It's so nice to have you here. Hopefully we can get you back and talk about PG sometime in the next couple